Well, hopefully everybody did a good job working with our OR problems with disjoint sets. Now we want to move on to complements. And so with a complement, what we're trying to do is find the probability that something doesn't exist. So this can be a pretty powerful tool because some of our complication or some of our probability problems can be a little complicated if we try to go straight at them. But if we attack them from a kind of a not perspective, sometimes it can actually turn it into a much easier problem to try to calculate. So with this one, I've got my little cards again, and so we did a little example here of what's the probability of not drawing an ace out of our deck. And if we remember, we've got our aces over here, and we've got 4 of them. So if we were to go through and kind of count all the other cards that existed, so we'd end up with 12 here, 12 here, 12 here, 12 here. And if I add all those up, I've got 48 cards that are not aces. And if I, again, put this over 52, that's going to give me my 48 out of 52. And so this method does work well as long as you're dealing with kind of straightforward one event probabilities. But if the probabilities get a little bit more complicated, we're going to have to use sort of another technique to go about that. So what we could have done instead is use the fact that, remember, all probabilities add up to 1 if we add everything together. Then if we think of this as 2 possibilities, we could say what's the probability of not an ace plus the probability of an ace. Then those are, covers every single scenario that could occur. So we know this has to equal 1. And so if we do a little algebra, we can solve for the probability of not an ace by subtracting P of A from both sides. And we can see that the probability of not drawing an ace is actually the same as taking 1 minus the probability of drawing an ace. And so that's what I've demonstrated in this little example here. So if we've got 1 minus the probability of drawing an ace, we know there's 4 aces out of 52. So I can get 1 minus 4 out of 52. Now again, to subtract this, if we're not using our calculator, we're going to have to get a common denominator. And so 1 is just going to be the same thing as 52 over 52 minus our 4 over 52. When we do our subtraction, lo and behold, we get the exact same thing that we got above. So again, if you're dealing with a single event, you can attack this problem either way that we talked about. But as our probabilities get a little bit trickier, this is going to be the go-to method that we're going to have to use in order to find our complements or find our not problems. Okay, so let's look at the definition here real quick. So the complement of an event A is denoted by the little A with the line over it. So that's when we see this. This means complement of A or not A. So keep that in mind. And again, our formula is to find the probability of not A. We're going to actually find the probability that A occurs and then subtract that amount from 1. And again, I wrote down underneath, so this is the set theory version of this. So the number of elements in A complement is equal to 1 minus the number of elements in A. Okay, so let's take a look at example here, see how we do on this. So if we pull a random card out of the deck, what's the probability it is not a heart? So again, this is one, it's a nice simple event. We could go through up to our table, just ignore this heart column and kind of add everything up, and we'd end up with 13 of these, 13 of these, 13 of these. And so if I add them together, I'm going to get 39. But I'm going to do it another way too, just so we make sure we see both ways. So in this case, if I go through, the probability of not a heart is going to be 1 minus the probability of a heart. And since there's 13 hearts in our deck, we're going to get 1 minus 13 over 52, which changing our 1 into a fraction. We end up with 39 over 52. All right, so you guys work on practice 5, practice 6, and I will see you in the next video for our and rule. So good luck.